Good morning all. I'm Dr. Gayathri NS, working as Assistant Professor of Chemistry in SNS College of Engineering. Today we're going to see about synthesis of nanomaterials, CVD. In the previous videos, a top-down, bottom-up approach we have seen, and the synthesis of CVD also we have seen. We directly move on to the main components of CVD equipment. There are two main component, hot wall and cold wall, and these are the picture of hot wall and cold wall tube and the effluent gas handling system. And the typical CVD process, the substrate is exposed to one or more volatile precursor which react and decompose on the substrate surface to produce the desired deposit. During this process, the substrate is exposed to one or more volatile precursor which react and decompose on the substrate surface to produce the desired product. During this process, the volatile byproducts are also produced, which are also removed by gas flow through the reaction chamber. These are the steps involved in the CVD process. First, the transportation of the reactants forced to the reactor, and the diffusion happens and adsorption on the substrate, and chemical decomposition and surface reaction takes place, and desorption and the transportation of byproducts by diffusion and transportation of byproduct by forced convection away from the deposition region. And the mechanism, the main glass flow and gas reaction, transport to surface, desorption and desorption of volatile surface reaction products. And these are the types of CVD: low pressure CVD, metal organic CVD, atmospheric pressure CVD, plasma enhanced CVD, photon laser induced CVD, etc. And this is the atomic pressure chemical vapor deposition, low pressure chemical vapor deposition, metal organic chemical vapor deposition, and laser. And the laser chemical vapor deposition are also focused through laser beam to heat the substrate. It also has the ability to locally heat a part of the substrate while passing the reactant gas, thereby inducing film deposition by locally driving the CVD reaction at the surface. It is used to deposit micro-scale solid patterns for three-dimensional structure on the surface of the substrate by localized single-step process. And plasma enhanced chemical vapor deposition, and advantages of CVD, it produces film, the ability of the film to be uniformly coated on topographically complex substrate, versatile, high purity can be obtained, high density, nearly 100% theoretical value, and CVD films are harder than similar materials produced using conventional ceramic fabrication process. The material formation will below the melting point, economical in production since many parts can be coated at the same time. It has disadvantages too. The chemical safety and hazards can be used by the toxic, corrosive, flammable or explosive precursors. Therefore, the extra steps has to be taken in handling the precursor and the treatment of reactant exhaust. High deposition temperatures, often greater than 600 degrees Celsius, are often unsuitable for structures readily fabricated on the substrate. The restrictions on the kind of substrate that can be coated. It leads to stresses in the film deposited on materials with a different thermal expansion coefficient, which can cause mechanical instabilities in the deposited film. Applications, the coatings for the variety of applications such as wear resistance, corrosion resistance, higher temperature protection, the semiconductors and related devices, integrated circuits, sensors, optoelectronic devices. Fiber optics for telecommunication, used in the microelectronic industries to make films for dielectric conductors, passivation layer, barriers, and many layers. Thank you.